Good afternoon, everyone. I'm Tom Duesterberg, a senior fellow at the Hudson Institute. Today we have a high-level panel to focus on the subject of creating an American 5G advantage. In recent years, Chinese competitors Huawei and ZTE have been moving up the value chain in terms of their offerings on telecommunications technology, especially 5G. Huawei has a very workable solution for the entire infrastructure package for 5G. The United States at this point does not have a single integrated 5G infrastructure player. There are competitors in Europe, Korea. We are focused today on ways to create a viable 5G competitor with significant American input. The United States is a leader in semiconductor technology, design of semiconductors, in computer software and systems integration. So we have a very good panel, starting off with Dr. Joe Evans from the Department of Defense, which has taken a leadership role in trying to use its resources to develop 5G technologies for its own use, but also for use in the private sector as well. Dr. Evans is the Principal Director for 5G in the DoD's Research and Engineering Directorate. Before joining R&E, he served as a program manager in DARPA's Strategic Technology Office. Earlier in his career, Evans helped develop the Tactical Ground Reporting System for DARPA. He also served as a program director in the Division of Computer Network Systems at the National Science Foundation between 2003 and 2005. He is on leave now from his position as the Akers Distinguished Professor of Electrical Engineering and Computer Science at the University of Kansas. And he has just recently issued contracts from his office for several, at least 5G demonstration projects on DoD bases. So, Dr. Evans, over to you.
Thank you, Tom, for that nice introduction. And what I'd like to do is provide a little bit of an overview regarding the activities at the Department of Defense in 5G, some of the ideas behind it, which I think align well with some of the thinking that we'll hear later today, and also talk a little bit about some of the activities that you mentioned that we're funding going forward. So if we could pull up slides. So we can go to slide 2, which talks a little bit about what we're trying to do at a high level. So really the fundamental observation behind why DoD is involved in 5G is that the U.S. networked way of war depends on telecommunications technology and our ability to essentially dominate that field. The U.S. and its allies have dominated telecommunications for a century, and we really need to continue that to support things like network drones, and then in the future, autonomous vehicles and distributed sensing systems and so forth. But really, we have this networked way of war that we've used over the past 30 years that depends on underlying telecom expertise and capabilities. And really what we are trying to do in our efforts is reinforce and reinvigorate that underlying industrial and commercial capability. The way we're approaching that is really focusing on two general objectives. One is to advance U.S. and partner 5G capabilities, or basically win at the technology fight, and then also heighten 5G security to win at the security fight. And we have different parts of our effort that are focused on those two general areas. In terms of advancing technology, we're trying to accelerate 5G technology with at-scale prototyping and experimentation at DoD facilities and throughout the department. So we view this in that there's two parts to this. One part is really at the high end of the value chain, where DoD is essentially an anchor tenant for advanced applications. Think of 4G example. Something like Uber would not have been possible without the 4G capabilities that became prevalent. Once you had that, then you could support that application. With 5G, we think that there's a similar argument that there are sets of applications that use the features and capabilities of 5G that will generate new industries that we would like to see from a industrial capacity point of view, but also have the department be able to utilize those types of applications. At the other end of the value chain, closer to the hardware, we are hoping to be able to commoditize or lower the expenses in the RAN, and we think we can do this via open interfaces, and essentially utilize US software excellence to help drive down the cost of systems in the RAN, and not just software, but also hardware examples, but really use interfaces, open interfaces to help to disaggregate the radio access network and be able to focus the activities of US companies and US startups and so forth on providing lower cost, more capable, more flexible capabilities. So that's the primary area in which we are advancing technology. We're also looking at security in our operate through part of the program. The operate through thrust looks at how we operate over non-secure networks. And of course, we want to exclude bad actors where possible, but we also want to make the market manipulations irrelevant by being able to work over untrusted network. We think that's important because DoD goes everywhere, anytime, and we need to be able to maintain the ability to use 5G capabilities, throughout the world. Finally, we do also believe that we need to establish the groundwork for the future, and so innovate at 6G, 7G, basically all the beyond 5G areas in order to succeed in the future. Across the board, we're reinforcing these thrusts with standards activities, engaging with industry that's engaging with the standards organizations, as well as engaging in international partnerships. The next slide, slide 3, just gives a little bit of an overview of the DoD 5G strategy, and this is available on the web at cto.mil. But, and I won't go into this in detail, but I just want to point out that we have specific activities that we're pursuing under each of those general areas. So you can think of promote technology development as our accelerate and innovate parts of the program, and assess, mitigate, and operate through 5G vulnerabilities as the security thrust within the program. And then we have, as I mentioned, cross-cutting activities in terms of influencing 5G standards and engaging with partners. The next slide, slide 4, talks a little bit about where we are now in terms of our different efforts. So we have kicked off several Kickstarter efforts and started performing some demos. For example, we showed an interesting demo involving the DARPA SHARE program with secure trusted endpoints operating over the NSF powder test bed, which provides some nascent 5G capabilities, and then backhauled that over SpaceX's Starlink network in order to demonstrate the ability to take those 5G capabilities anywhere in the world. So that was just one example of our Kickstarter efforts, and we have several others. At a larger scale, we've also kicked off our tranche one of experiments with over 3 dozen contracts, over 100 total companies, many non-traditional companies. And they are providing or starting experimentation and prototyping at the 5 locations listed on the right hand of this slide, with a range of areas of focus, ranging from dynamic spectrum sharing at Hill Air Force Base to AR/VR for distributed ground combat and potentially in the field use at Joint Base Lewis McChord, smart warehouse projects with slightly different focuses at Naval Base San Diego and Marine Corps Logistics Base Albany, and finally distributed command and control, disaggregating a combined air operations center at Nellis Air Force Base. Should mention that several of these examples or most of these examples have dual use or parallel use in the military world and the commercial world. So, for example, the smart warehouse projects are clearly, very similar to warehouse and logistics types of work being done in the commercial world to support the various shipping companies and so forth, with the slight change in flavor that comes with being implemented, something being implemented at a DoD facility with things like weapons and other high value items being handled in those warehouses. So we intend to continue a lot of that parallel use, dual use emphasis as we go through the program, because we think that's one way to make sure that DoD is leveraging industry to the greatest extent possible. The slide also shows that we're looking at a mix of different technologies, ranging from the RAN to applications to various other pieces such as 5G core that are necessary in order to provide a complete solution for DoD and provide opportunities for US companies to excel. The next slide, slide 5, just gives you a sense of the size and scope of what we're doing. So this is just laying out the some of the performers, the contractors that have been announced for the initial 5 sites. And just want to make the point that it's a large investment, $601 million over 3 years. We believe it is by far the largest dual use 5G testbed initiative in the world. So DoD is really pushing forward on how we accelerate 5G for DoD. The next slide, slide 6, brings us to what we're doing next. And so we have several solicitations that are due to hit the streets, or in some cases have already been released. So these focus on a range of topics, both dual use and very tactically oriented. So, for example, with the Navy at Naval Station Newark, focusing on how you use 5G on a ship, or when the naval vessel arrives at a dock. Obviously, there's similar types of uses of 5G might be pursued in the maritime and industry as in many of our examples. We also have things like enhancing aircraft mission readiness. So the idea there is download data, various sensor data, maintenance tracking data from aircraft as they arrive at the flight line. And again, there are dual uses there. The commercial aviation industry is very interested in this topic as well. How do you use the high capacities that come with 5G, for example, to quickly download that data when you're trying to turn around an aircraft in 30 minutes or less. So yes, like I say, several of these have dual uses. Another one that is very much a dual use application is augmented reality for medical training and telemedicine. That's both useful for DoD to make its medical training operations more efficient and effective, but also telemedicine, the use of these capabilities in the field is also very valuable, being able to reach back from a medical event on the front lines back to specialists and involve those specialists in an immersive way in the situation, it would be a tremendous capability. Another very much dual use application that we're looking at is 5G enabled immersive training and education. And you can think of all the problems that parents have had in terms of educational situations for children, trying to make that situation better. The DoD has many schoolhouses and educational institutions that also need to work in a distributed fashion now. This type of technology will help us do that. Finally, I mentioned that we have several experiments that are looking at tactical situations. So tactical operations center or combat operations centers, and how you disaggregate and make those more secure as well as more efficient and more survivable. And also things at a large scale, a project at a large scale where we're looking at a 5G core security experimentation network that spans not just one site at Joint Base San Antonio, but many of the bases that we're using for other experiments, in order to provide an opportunity to study interoperability as well as security across different instantiations of 5G software and hardware. And then just to wrap up, I should mention that we have a couple of other thrusts happening very soon now. We have the Operate Through and Innovate thrusts. We have broad agency announcement BAAs in preparation. Those solicitations should be issued in early FY21, pending the budget and funds availability. And so with that, I think I can hand it over and answer a few questions.
Okay, thank you, Dr. Evans. I have one question on software and one question on hardware. And let's start with software. One of the advantages that we think in using software-based virtualized systems is flexibility that it provides, as well as US advantage and superiority in the software field in general. From the DoD perspective, security is absolutely paramount. Does moving to more software-based systems provide greater security in your view than are available than traditional hardware-based proprietary systems?
So that's a great question, and I think it really offers both opportunities and challenges. I think to take the challenges first, I think you'll often hear from the security community that there is concern that moving to more software-based capabilities increases the attack surface, increases the opportunities to find vulnerabilities in network systems. So we think that that's a challenge going forward. One of the ways that we are looking at alleviating some of that is moving towards this idea of zero trust architectures, trying to ensure that all layers of the network have security thinking embedded in each of those layers, and make prolific use of encryption and signing and role-based authentication, all those sorts of types of authorization and authentication tools that are available, have been developed by the security community over many years, but really need to be brought together and embedded into the overall network system. So we think there are some challenges there, increased attack surfaces, but we do believe that there are a lot of tools that can be applied to solve those problems. On the opportunity side, we see tremendous opportunities in terms of flexibility. And in some cases, that flexibility is also an opportunity to address some of the security problems. So think of the ability to send your traffic along multiple paths, or to embed network functions that provide security capabilities along the way within the network using the network function virtualization concepts. So we think there's some interesting ways, opportunities presented to kind of embed secret sauce within the network using these virtualized functions that was never possible in the past. So I think there are like I say, opportunities and challenges, but in general, I think we view it as a great opportunity for DoD.
Okay, on the hardware side, there's a lot of controversy and perhaps needless worry about the United States falling behind China in terms of the technologies that are key to 5G systems and other advanced systems. DoD has a long history of developing, encouraging the development of key technologies, and you've been at DARPA, which has been one of the leaders over many years in that. Could you comment on what types of hardware technologies DoD may be focused on to assist in this effort to gain leadership, or protect leadership, let's put it that way, in 5G?
Definitely, and I think as mentioning earlier, I think there's several areas of the radio access network piece of the puzzle in which we want to invest and help drive down costs as well as increase functionality and provide opportunities for U.S. companies to excel. For example, we are very interested in some of the multi-antenna systems for mostly in the commercial world, looking at things like massive MIMO and so forth for higher throughput and greater coverage. But we also view it as the flip side of that coin is it's also useful technology for things like beamforming that allows us then to control our RF emissions, which makes it harder to target our systems and people. So we think that's one example of a technology we think is very, very exciting. But there's certainly lots of others. Spectrum agility is very important to us. Again, that makes it harder to find us and makes the entire problem harder for an adversary. We think those are technologies that are important. And then kind of in a completely different flavor, we also believe that it is important to kind of understand the security of the hardware systems from the ground up. And certainly, some of our colleagues at DARPA have looked at this over the recent years. The idea of being able to essentially harden and understand systems from the ground up, so that you can ensure your security properties, as you go forward. So it's hard to build secure systems, on completely untrusted hardware. So how do you build, from the ground up? So we think those are some areas of interest. I should say that's not meant to be an exclusive list. That is, just a couple off the top of my head remarks on those. And, we're frankly looking to hear from our partners in industry to tell us what the new and exciting ideas are.
Well, we have some of the leaders in the industry later in this program. I think we have time for one final question. The Department of Defense has worked constructively with some of our leading allies on many initiatives in the past and going into the future. We don't have a monopoly on all of the technologies that are going to go into 5G. The Europeans, Japanese, some of our friends in Canada and Australia also have something to offer. Could you just generally characterize how open DoD is on some of these initiatives in the 5G world to work with our allies?
So I should say we are extremely open to that idea. We, as you're saying, we believe that there are great capabilities in allied and partner nations that we can bring to bear to make all of our systems more better and more secure. We have had initial outreach with several of our allies, and we're looking to continue that. We think that there's possibilities of joint projects, involvement at the test beds in some cases. So we're definitely looking to reach out to allies and partners to deepen those relationships and start some on the ground work together.
Okay, well, thank you very much, Dr. Evans, for these really illuminating remarks in this discussion, and we wish you the best in your endeavors there. So,
thank you.
Let's move into the next part of our program, where my colleague Bryan Clark and his associate Dan Patt are going to present a summary of their study, Weaponizing the 5G Chain, which appeared in September, and I might mention that it was a project for the Department of Defense, but it's available on the Hudson website. Bryan Clark is a senior fellow and the director of the Center for Defense Concepts and Technology at Hudson. He's had a distinguished career in the Navy, starting as an enlisted submariner and then as chief engineer and operating officer of the Navy's nuclear power training unit. After retiring from active service, Bryan served as an assistant to the chief of naval operations and conducted studies for the DoD Office of Net Assessment and for DARPA. He is an expert in naval operations, electronic warfare, autonomous systems, military competitions. And again, I commend you to the study that he's written with Dan Patt, Weaponizing the 5G Value Chain. So Bryan, over to you.
Thank you, Tom. I appreciate it. One point of clarification, the study we just completed was in coordination with DoD, but wasn't sponsored by DoD. So we completed that study on our own, but you'll see there's a lot of parallels between what Dr. Evans talked about and what we'll talk about today. So I'm going to present the study. My colleague Dan Patt, who did this with me, is on the line as well, so we can talk with him later during the question and answer period if we want to. I'm going to share my screen so I can go through the slide describing the brief. The study we pursued as a way to develop a competitive strategy for the United States to pursue to try to establish a more competitive 5G industry in the United States and try to maybe undermine some of the strengths of foreign competitors, and particularly Huawei, who is currently the largest player in the 5G network infrastructure industry, but is by no means the only player. And you'll see that there are a lot of parallels between the things that we're recommending in this study and some of the pursuits that DoD has. Our goal with this study was, when we developed this strategy, to identify some ways that the US government could facilitate a more competitive strategy to enable a US 5G industry and to allow a US 5G industry to proliferate more widely and thereby eliminate or address some of the security concerns we have with maybe a Chinese predominant 5G network worldwide. So to go through the main findings of the study, I guess the main recommendations of the study I'll talk about later, but the main findings were that currently we have a series of export controls in place and bans that are denying Huawei access to US-built microelectronics and US design tools and manufacturing tools that could be used to build microelectronics. Those export controls and bans are useful in a competitive strategy, but they're really only a temporary measure. Eventually China will build its own domestic supply chains. They'll work around these export controls. And so we can't rely on them being the whole of our strategy to try to establish a competitive US 5G industry. We need to do something else while the Huawei is dealing with the current challenges imposed by the export controls. And what we think we need to do is create or cause the US 5G industry to emerge more quickly than would it otherwise do. Because right now we're concerned that if it left to its own, the alternatives that the US is pursuing, or that US companies are pursuing, are going to emerge by the time that Huawei has already recovered its supply chain and is able to compete and use its current market advantage against us. So to catalyze the emergence of a US 5G industry, we're proposing a two-pronged strategy, where there's a high part of the strategy that is focused on the emergence of a more virtualized 5G core network and edge network that I'll talk a little bit about later, sort of what we discussed just now with Dr. Evans. And then there's a low part of the strategy as well to try to improve the US network providers' capability to field radio access networks that are on par with those delivered by Huawei, but offer advantages in terms of cost, adaptability, and composability for particular customers. So I'll talk a little bit about the basis for this strategy and kind of our recommendations that fall out of it during the course of the brief. To step back, though, to kind of talk about what 5G is and make sure that we're all baselined with regard to the component elements of it and how those come together to be able to facilitate this more competitive strategy. We'll talk a little bit about what does 5G consist of. And I think it's important to make sure that, that policymakers understand that when we talk about 5G, it's not a complete, I guess it's not a specific network instantiation like we would have with 4G, where there's maybe only a couple of variables in terms of how the 4G network is laid out. 5G is much more adaptable and much more specialized, or can be much more specialized. And that's because it's a collection of technologies rather than being a specific network architecture. Those technologies that are on this slide cover the gamut from how do you get information into the electromagnetic spectrum and out of the electromagnetic spectrum through the translation of that into waveforms that then can be picked up or transmitted by radio hardware, and then the network that sits behind that radio hardware to translate that information into something useful, and then be able to move that information around via a computing architecture. So each of these elements are key technologies involved in making a 5G network a reality. They also create essentially a competitive landscape between the US equipment providers and mobile network operators and those of other countries, for example, China and Huawei. What we're seeing right now is that, that you might say that the Chinese have an advantage on the left side of this competitive landscape. So we just had a discussion about trying to come up with ways to share spectrum between US commercial and civilian uses and military uses. This competition and the conflict between different users in the spectrum in the US has created a lot of churn. It's going to create need for dynamic spectrum sharing technologies, and those are going to be necessary for 5G to really pick up in the United States to a degree. Over in China, there's been a much more, obviously, authoritarian approach to making spectrum available to 5G users. And as a result, perhaps they've been able to advance their technologies or advance the fielding of their networks more quickly than those in the United States. In terms of waveforms, you could argue that there's probably a very level playing field there, where the US has some very effective waveforms. The Chinese have argued they have effective waveforms for things like multi-input, multi-output, or MIMO technology, which allows you to communicate simultaneously with multiple antennas, which is one of the ways that 5G is able to generate the capacity and the bandwidth that it's able to provide compared to 4G. In radio hardware, the Chinese and Huawei have put a lot of money into developing next generation technologies that are able to be more efficient and offer performance on par or potentially better than what's available in Western countries or Western providers like Ericsson, Nokia, and Samsung, et cetera. And then in the network architecture now, arguably there's an advantage that's potentially, or that is available to the US in network architecture and cloud computing. These companies like Microsoft with Azure, Amazon Web Services, Oracle, et cetera, have all put a lot of money into developing cloud and computing architectures for a variety of uses that could be leveraged to facilitate 5G network virtualization. So this is an area where the US might have a competitive advantage, and that could be leveraged. So we think this competitive landscape is really the heart of where we should be thinking of developing a competitive US 5G industry. In thinking about 5G, there's a way to view it that allows us to maybe talk about this competitive strategy in a little bit more detail. So there are essentially five ways of thinking, or rather, there are three ways of thinking about the 5G architecture. The first way of thinking about it is its physical architecture, which is the physical design of the equipment in the network. There's user equipment out in the field, our cell phones, our mobile tablets, et cetera, that access the radio network. Then there's a radio access network, which consists of mobile phone towers, associated baseband processing equipment that then takes that information, or does the transition from electromagnetic energy into digital energy or digital information, and then that's transmitted to a core network. So between 4G and 5G, there's a lot of similarities in terms of the network physical architecture. A lot of the same pieces are there. It's just that those technologies have to be advanced to enable 5G because we need the higher bandwidth. We need to use capabilities like multi-input, multi-output radio antennas. So there's new technologies necessary to transition to 5G in the physical architecture, even though in general, the same kinds of pieces are needed in both networks. 5G also has a functional architecture, and that functional architecture allows you to now configure your radio access network and your core networks to deal with user needs. And so you can organize your functional architecture in a way, for example, that allows you to have a large number. If you look in the third from the left case there with the dual split radio access network, you can create a network where you have a large number of radios out in the field to allow for high bandwidth, low latency communications between individual users, for example, autonomous cars or warehouse robots that are managing warehouse inventory. And they're all communicating with one another via the distributed unit that is the central hub for their communication. So the DU stands for the distributed unit, the RU stands for the radio unit. That architecture allows you to functionally manage this very low latency, high bandwidth communication between a large number of users out in the field somewhere, and then only access the main network, so the centralized unit, when necessary to get information to and from the core network or the rest of the internet. So you can configure your 5G network in lots of different ways functionally to deal with particular specialized user needs. And you'll see this in 5G instantiations where the functional equipment, the functional layout is much different from one user to the next. There's also a logical architecture for 5G, which is done via software. And this gets to what we're talking about with virtualization, is that the same 5G physical and functional architecture can be organized in lots of different ways using software to allow you to then split these network functions up between different uses. So you can slice, which is what the term of this is, using software, your 5G network up into a series of subnetworks that allow you to provide specialized services to particular users. So for example, mobile internet to your traditional users like we're all familiar with today. Or if you want to be able to facilitate autonomous cars to understand where their fellow autonomous cars are through cooperative sensing, that can be provided via a slice of the network that is now organized around providing that high bandwidth, low latency communication between individual cars and maybe between the road network sensors, but no actual connection back to the broader internet. And then separately within the same physical and functional architecture, you could have software and remote monitoring for maintenance for the cars to be able to transmit their data in terms of their condition back to a equipment manufacturer who can then monitor the equipment to ensure that those vehicles don't need maintenance soon. So there's a way to do that via software, and that's the logical architecture. So there's three different ways of splitting up that 5G network and thinking about how it's structured. That's important because there's value chain implications for them. The physical architecture is the one that we're focusing a lot on today with the radio access networks and how they're structured and the kinds of equipment that goes into them. But over time, the importance of these other architectures are going to grow. And eventually, the value of the 5G network is going to reside much more in the logical architecture in terms of the virtualized services it can provide to high-end users. And this is where a lot of the money is going to be in future 5G network operations. So if you think about the way that that business model works, this is the value chain for kind of today's network operator, which is it's vertically integrated. You go to your mobile network provider, they've accessed spectrum, they've built a radio access network, they've built all the architecture and the physical and functional capabilities to get information to and from that spectrum for you. They even sell you their mobile phone, and you even probably get your mobile phone replaced by them periodically. So as the end user customer, you're dealing with a completely vertically integrated organization that provides essentially value to you from spectrum. The Huawei model, which is a variation on this for 5G, builds on this by offering mobile network operators this vertically integrated, highly refined solution as a one-stop shop. So when they go to a mobile network operator, we're always able to say, well, I'm going to replace your 4G network, this 5G network in a turnkey way that you don't have to do any of the integration and our network architecture work yourself. You'll just essentially be handed a network and you can begin operating it, and Huawei will provide the support to it. Huawei's focus, though, in this has been on the physical and functional architectures. They've been focused on the putting out a combination of RUs, DUs, and CUs that can then deal directly with the mobile network customer. But they have not put a lot of work into the network and computing management necessary to do the more virtualized architecture. So the logical architecture we talked about has not been leveraged by Huawei in its current offerings. So there's an opportunity here for the US providers or alternative providers to come in and offer services that Huawei is not currently focusing its value chain on. So this provides a potential opportunity. There's also challenges that Huawei has. So there's opportunities available to US providers, and then there's challenges that Huawei has in terms of its own internal value chain business model. So in Huawei's case, they have a very robust supply chain and R&D effort that's common with the consumer phone business, which has really been the heart of Huawei's business model for several decades now. The revenue from that mobile phone business, as well as a lot of the technology from it, is then harvested and used to help their 5G network installation. So they want to be able to take advantage of that investment in mobile phones, translate that over to their 5G infrastructure networks, and then be able to offer a fully integrated solution of phones and networks to potential customers. There's a vulnerability here, though. One has been revealed by the export controls recently put in place by the US, which is the supply chain, highly dependent upon US built microelectronics, and more importantly, US built design tools and manufacturing equipment. The fact that those have been denied to Huawei has now caused them to not be able to get the highest end chips, the 7 nanometer and smaller gap size chips that are needed for their flagship phones and for their new 5G radio access networks. They will also suffer from a reduction in resources because they're no longer able to access the Google Play Store, which has been a very attractive element of their business offering for their mobile phone business. So those supply chain weaknesses are going to now kind of manifest themselves through the business model for Huawei. At the same time, as we noted earlier, they've got this weakness in the cloud computing, the network architecture side, the logical architecture for 5G that could be exploited by a US strategy. So these two vulnerabilities point out basically the two elements of the US strategy that we're identifying. And so a way to think of this is the classic disruption model. So this is from Clayton Christensen's work on business disruption. But essentially what we have now is Huawei is offering a highly integrated solution that probably exceeds what customers need in a lot of cases. It's unclear, and customers are unable to exploit a competitor because there's not really a non-integrated competitor that they're able to buy instead. So a good analog for this would be the IBM PC of the late 80s, early 1990s. Highly integrated solution, very capable, designed for kind of a high-end user, and that works great unless you're a home computer user and you don't need the functionality provided by that very high-end IBM solution, and you would like something less, maybe with a little less performance, but a lot less cost. So that's where Dell and Compaq and these more disaggregated assembly companies come along that buy equipment from other suppliers, assemble them to create a PC that's maybe not as high performing as the original IBM PC, but is less expensive and can be specialized to a degree that the IBM PC cannot. So in this case, you have Huawei with this highly integrated solution. It might exceed what customers really need or want in a lot of situations. It's also potentially more expensive than what would be possible with a more open solution. So with Open RAN, the open architecture approach to 5G, and with the emergence of some 5G equipment providers that can provide equipment that's performs as well as Huawei's or better, and that could be assembled through Open RAN, you could end up with this disruption where these more disaggregated integration companies come along that are able to create 5G networks with more specialization or more adaptability and a lower cost than what 5G or what that Huawei is able to provide. So we see this as the disruption model that could be pursued as part of this two-pronged strategy for US gaining a 5G advantage. So to that end, we propose essentially three main recommendations that get at the two prongs of the strategy. So on the low end of the strategy, which is the focus on improving the US RAN or the US RAN offerings or US RAN capabilities, is one, address the hardware issues. We need to invest in microelectronics to get them to comparable or better performance than those available from Huawei. And that involves improving the radio access network efficiency and the ability to conduct MIMO or massive MIMO operations. And there's opportunities here for the government to invest in this. So investment through programs like the CHIPS Act, which is currently being considered by the Congress, by the American Foundries Act, offer opportunities for the US to invest in semiconductors and microelectronics that would help facilitate the emergence of a RAN hardware ecosystem that could be harvested for an open RAN competitor to Huawei in the United States. The other element of this, which is the second recommendation, is we need to come up with ways to promote the emergence of integrators that are going to pull together the pieces of a RAN ecosystem to create actual 5G radio access networks. So we need the counterpart to Compaq and Dell of the 1990s. They're going to come along and assemble parts from suppliers and create 5G networks for mobile network operators. Because Verizon and AT&T may not want to be in the business of having to be that integrator. They would probably prefer to have somebody else come and do that work, to offer a competitor to Huawei, which does offer this integration as a turnkey operation. We have to provide a similar kind of turnkey operation to mobile network providers for this strategy to work. And then on the high end of the strategy, we need to focus we need to accelerate the shift up the value chain towards the virtualized networks that are going to be the future of 5G. Because the radio access network recommendations here that we are making are going to tend to drive it kind of like the PC industry towards the radio access network being increasingly a commoditized offering that's going to encourage something of a race to the bottom in terms of cost as each RAN provider attempts to provide the lowest cost option with the acceptable performance to customers. So as that low end of the strategy drives us towards a commoditized RAN, at the high end of the value chain, which is the virtualized networks using logical architectures and slicing to provide specialized services to users, we need to encourage those companies to emerge as well. So cloud providers and computing companies today that are focused on more about the cloud computing services need to be encouraged to come into the 5G ecosystem. That's already happening to a degree, but it could be encouraged through the work that, for example, Dr. Evans is doing to do demonstrations of 5G capabilities using DoD money that would allow the emergence of a network operator or rather a network integrator ecosystem to bring cloud providers into the 5G ecosystem. And then what that would do is give us this network or this value chain for the United States where you've got different mobile network operators will have different organizations of RAN hardware being integrated by an integration specialist, and then cloud and network management capabilities from cloud companies like Azure, like Oracle, like Amazon Web Services are being then organized and integrated by network and cloud specialists for them. So the network operator is able to harness a more disaggregated set of providers through some integration services providers to be able to provide services to end users. This ecosystem is going to give us a US competitor to a Huawei while simultaneously promoting the emergence of the Open RAN ecosystem that is probably going to be the future of 5G. So that's the recommendations and the study findings. So I'll turn it back over to you, Tom, and I'm really interested to hear what our panel has to say about their thoughts on how to develop a 5G industry in the United States. So thank you.
Okay, thanks, Brian. I think in the interest of time, we'll move into the panel discussion, and maybe you can jump back on when we get to the Q&A for that. But I think we've focused on 5G alternatives. I just want to emphasize it's a huge business opportunity for all suppliers. The 5G rollout is going to take huge amounts of capital investment. The payoff in the long run, especially as it enables new services like the Internet of Things and autonomous vehicles, is enormous. So hopefully our final panel can illuminate some of those opportunities and also give us insight into where they think the things stand with regard to American leadership in these technologies. So quickly, we have three very distinguished panelists, starting with Chris Boyer. Chris is the Vice President of Global Security and Technology Policy at AT&T Services. He's responsible for the company's global policy positions related to cybersecurity, national security, and technology policy. In his over 25-year career with AT&T, Chris has performed a number of roles. He was AT&T's policy lead, working with the high-tech community in Silicon Valley, and has held positions in the company's corporate public policy, network planning, and engineering, product marketing, and network services departments. Notably, too, Chris is the chairman for the Open RAN Coalition, a coalition, I think over 30 companies now devoted to finding ways to promote Open RAN, virtualized network solutions. Next, we have Cheryl Davis, is a Senior Director for Strategic Initiatives at Oracle. Cheryl's had a distinguished career in government of late. Previously, she served as the Director for Cyber Response Policy at the U.S. National Security Council, where she led the development of the whole of government responses to malicious cyber activity that threatened the United States and its allies. Before that, she was a Principal Director for Cyber Policy at the Department of Homeland Security, and also served on the staff of the Office of the Secretary of Defense, where she focused on cyber and intelligence policy issues. Prior to joining the government, Cheryl conducted research and analysis for the Center for Naval Analysis, as well as the Penn State Applied Research Lab. And Oracle, of course, is one of the leading cloud computing providers in the country, in addition to its software business. Last but not least, we have Steve Papa. Steve is the co-founder and CEO of Parallel Wireless, where he leads the senior management team in setting the company's strategic direction and guiding the company's evolution towards a broader commercialization of its innovative technologies in telecommunications. Parallel is the only US company challenging the world's legacy telecom infrastructure vendors with the industry's only unified, calls it all G, that is 2G through 5G software-enabled solutions. They were able to adapt legacy systems to modern 5G virtualized Open RAN type systems. He has been in leadership positions in the high technology ecosystem for over 20 years, including such companies as Endeca, Akamai, Inktomi, and AT&T Teradata. So we're going to ask each of our panelists to give roughly 5 minutes of opening remarks, starting with Chris, and then we will go into a short question and answer period as we have time. So, Chris.
Great. Thank you, Thomas. I really appreciate you inviting me here today. It's a privilege to talk to such an esteemed group. Just to start with, I thought that Bryan's presentation did a fantastic job of kind of framing the issue and kind of the vision of the future that a lot of us have around how to create a more competitive ecosystem for telecommunications equipment. I would call it 5G, but I would actually say this will live on beyond 5G into whatever we call the next iteration of the next G. But I think his vision that he laid out around disaggregating the industry, creating a much more competitive and vibrant supply chain is something that we have a lot of interest in. Kind of taking it back full circle. So why is AT&T interested in this issue from an Open RAN perspective? Fundamentally, and I think Bryan framed this, we've been concerned for a while now around a contraction in our suppliers, particularly in the radio access part of the network. And I think Bryan laid this out, that if you look at it, a year ago, you would have said that, and even today, the primary vendors are Nokia, Ericsson, and Huawei, and Samsung to a lesser degree. And if you look at that breakdown, and you assume that Huawei, for whatever reason, has these security challenges, most U.S. operators or the U.S. operators are precluded from using them. That really leaves you with a couple vendors between Nokia and Ericsson. And the question is ultimately, is that a healthy ecosystem, and is that going to lead to the right level of innovation and the right characteristics for a vibrant 5G solution in the long run? And I think what we've been largely interested in is how do we incentivize a much longer tail in the supply chain and more innovation. And I think the government side of that's been interested in how can we foster a US based version of a supply chain. So I think that's kind of how we came at this issue. That's why we founded the Open RAN Policy Coalition. We're one of the founding members. I think there were about 30 companies that were originally founding members of the ORAN Policy Coalition, or the Open RAN Policy Coalition. Right now we're at, I think, 55 by my count this morning of the number of members. It really spans a wide cross-section of industry, both in the US and outside. So from a carrier perspective, you have AT&T and Verizon and US Cellular, who are US operators. Internationally, you have Telefonica and Vodafone, among others, who are involved. So we really have a wide we have some of the biggest operators in the world. And then on the vendor side, you have companies like Steve's company, Parallel Wireless. You have companies like Mavenir and Altiostar, who are smaller, more startups oriented towards this issue. But you also have bigger players that are part of the coalition as well, like Cisco, Google, Facebook, Intel, Qualcomm, et cetera. So it's a huge cross-section of industry. And what it really shows is that all of industry is largely, moving in this direction. And just to give a quick explanation of why Open RAN matters, the main reason that it's an important issue to facilitating the vision that Bryan laid out is that in previous generations of wireless, typically the interfaces between the various components that go into the radio access network are proprietary to the vendor. So what I'm talking about here is the interface between the radio and the hardware and the software, and when you build out the network. So if you're building a network, you would build it out and you would say, okay, I'm going to use Nokia, for example, I'm going to use Ericsson, and all those components were provided by that particular vendor. So when networks were built, you typically built them on a geographically centered basis. So you would build a network using largely Nokia RAN architecture in a given geographic region, like the Washington, D.C. area, or like the New York region, right? And in order to ensure that we have a diverse supply of vendors, a lot of the operators would mix and match. So you'd have Nokia in certain areas, Ericsson and others, and they would go to a common core. But those interfaces between the radios and the hardware and the software were really proprietary to the vendor. The concept of Open RAN is really, how do we standardize and open up those interfaces so that instead of all those components being provided by a single vendor, we can move to an environment where you can disaggregate that, and you can have a radio from one company, potentially hardware from another company. You might be able to use commonly off-the-shelf, kind of COTS hardware, and then you could use software from a third company, or even use open source software, depending upon how you want to configure the architecture. And what that does is, by standardizing those interfaces and opening them, it opens up a whole range of possibilities where telecom infrastructure, frankly, starts to look a lot more like IT infrastructure. So now you can have mixing and matching different hardware components, different software components. You can still go with the old model if you want to, but it really creates this a much more vibrant ecosystem. And from our perspective, it lowers barriers to entry, because now if you're a company who wants to get in the space, you're not looking at having to build a whole stack of vertically integrated equipment and compete with the Nokias and Ericssons and the Huaweis of the world. but you can really focus on particular areas of the stack that you really want to develop and focus on, whether that's the software part of it or whether that's virtualization, as Dr. Evans spoke about, or software-defined networking, or even investing in radios. So we think that Open RAN, which is really focused on standardizing the interfaces, is kind of a prerequisite to enabling kind of this broader ecosystem of suppliers. And that's why we focused on it and formed the coalition. And then the last thing I'll say is, from a policy perspective, we've been having a lot of conversations as a coalition with the U.S. government and also governments around the world about how to drive, really accelerate this kind of shift. I think we're making a lot of progress there. There's been various proposals in Congress to provide funding for R&D support, that goes towards things like Open RAN. So I think there's remedies out there. I think a lot of the things that Bryan spoke about actually fit pretty consistently with what the coalition's been advocating for in terms of ways in which we can kind of accelerate this change. So with that, I'll wrap up my comments, and I'm happy to take questions.
Okay, we'll go to the other two panelists first, Chris, then go to Q&A. So Cheryl, over to you.
Hi. Yes, so thank you so much. I very much appreciate the opportunity to be part of this discussion today. What I thought I'd do is just offer a few thoughts from our perspective. Oracle, as a major cloud provider, software company, and global telecommunications provider, we are very excited about the prospect of what 5G will bring. Right? We see 5G as really this generational shift to an entirely IT-based infrastructure. So replacing all that purpose-built hardware with software running in hyperscale clouds. And so what this does is shifts the ecosystem, as we've been talking about, from that fragile telecommunications equipment supply chain to a more agile, competitive, and robust IT technology supply chain, while also adopting some new economic models too that can potentially change the game in deployment and future growth. So, while much of the conversation, certainly today, and policy conversations have focused on the radio access network, which is one of the gateways to 5G networks, as it's now moving towards virtualization, and as Chris laid out, the push for open and standardized interfaces, that's certainly important to us as a 5G core provider. That we need to ensure that our solutions can integrate with whichever access means our customers select. Cellular or otherwise. But we do also like to keep in mind that the features and capabilities of 5G get delivered by a core network hosted in the cloud. And so we also find it useful to recognize that 5G is really not about providing those faster download speeds to a consumer smartphone. And in fact, the 5G standards were written to address IoT specifically. And so, this is all to say that, we really see the value in the applications that 5G will enable, and what happens when you can connect those billions of things to other things. And so, the importance is really focusing on the applications, or the what, as we've discussed today. And so while we continue our 5G deployments and whatnot, focusing on those applications will really help us to drive innovation. So we're very excited to see the Department of Defense take such a leadership role here and just start testing out what's within the realm of the possible for the use cases of 5G. And I think their efforts through pilots really send a strong signal to industry that it is important, to mobilize, and we'll be right there to innovate with them in this space. So I'll end there, but I look forward to the discussion, and thank you very much again for having me.
Okay, thanks, Cheryl. Steve, over to you.
Nice to have a chance to participate here. So the challenge is a lack of innovation. And when you have vertically integrated companies, they slow it down. They're only as good as their weakest link. And I think that was explained very well with some of the slides that we saw. So what is possible with innovation in the cell network? The cell network is 10 million cell towers. My belief is 10 years from now, well, today it's a bunch of sheet metal known as passive antennas, RF cables, brackets, it's a big mess. By the end of this decade, it's going to be the world's largest supercomputer. You're going to have fiber optic cables to each of these towers with more compute on the top of that tower than is in a data center rack today. Think about that, 10 million data center racks. That's what's going on. We're moving from an analog heavy wireless world to a digital heavy wireless world. That inflection point is as big as the move from, say, laptops to mobile handsets. one that Intel couldn't navigate and had to cede to ARM. Okay, so some of the points made about how we beat Huawei in this innovation game. So for instance, how do we drive semiconductor costs down? Well, Intel famously succeeded because it was their low-cost PC chips that enabled them to transform the data center. It was an interoperability layer such as Linux that made that possible. Well, what we have going on in 5G, but really I think of it as a decade-long shift, is we're moving from analog heavy to digital heavy, which drives a lot more semiconductor content. We're getting our interoperable interface, which is the O-RAN interface. That's really what that's providing. And you start to be able to take that compute power and do things such as, why wouldn't you do radar from each of these cell towers? Why wouldn't you look for a malignant drone, something you can't do from centralized locations very easily? Remember, the core technology in 5G is active antennas. That's the MIMO stuff that was alluded to earlier. That's derived from phased array radar. You know, why can't we be using these 10 million cell towers to solve our PNT resilience problem that we have with satellites in outer space? We have this terrestrial infrastructure that's really hard to take out because it's so distributed. So these are the things that will be happening as we go on this journey to enable some of the applications described, but the fundamental infrastructure, it's turning into the world's largest distributed supercomputer, okay? At Parallel Wireless, what we're trying to do is both solve the software needs of infrastructure, so that the comment about all G is quite critical. One of the cardinal rules of the cell network is thou shalt not regress the capability. And for most of the world, take our, you know, our partner, the UK. They have 15 million gas meters on the 2G network. They aren't turning off the 2G network for another decade. So the only way they can move to Open RAN is if we're able to bring those legacy technologies forward, right? But that just gets us an alternative, right? It's the software that allows us to be an alternative to what they currently have deployed. And we're building what I would call tier 2 networks now. We have 1,000 site network for Telefonica. And next year we should be building tier 1 networks. Vodafone works very closely with us on our roadmaps. But if you want to disrupt Huawei and not just be an alternative, that comes from semiconductor innovation. This shift to an all digital network versus an analog heavy network comes with huge CapEx and operating expense implications. There's some people projecting just the energy costs for these digital heavy networks become 12% of the revenue of an operator. Think about that. 12% of your income going to the electric bill. And the only way these things are going to be addressed is through semiconductor innovation. So I applaud the study and some of the conclusions. I wholeheartedly agree that the go high on the more advanced orchestration to create differentiation from Huawei while taking away their superpowers. And just to summarize their superpowers, it's been their investments in wireless technology, but it's also their ramped supply chains. They're the world's largest supplier of passive antennas to the cell network, which means their costs are less than half of what it would take for me to get an equivalent device, even when I'm at scale. And so if I try to compete with them against their strengths, I will fail. On the other hand, if we change the playing field to digital heavy technologies, we take away their strengths and we start a race anew in the same way that, you know, when ARM and Intel competed, Intel's strengths in laptops was suddenly a weakness. And that's what's happening as we move from 10 million cell towers with a bunch of sheet metal on top to effectively the world's largest supercomputer. So I'll leave my comments there for now.
Okay, thanks, Steve. Maybe all the panelists could get back on video so you can comment on the questions. And I'll start by saying if any of you want to comment on the other presentations by your co-panelists, please jump in. I do have a question, I think mostly for Chris and Cheryl, and that's that there's a fair amount of discussion about who controls the standards making? Huawei has been very aggressive in recent years in trying to use its abilities to send large numbers of people, file large numbers of patents, and try to get international standards for especially 5G. And China has a 2035 program to dominate the standards of the future. So would either of you want to comment, or both of you want to comment on how we're doing in terms of starting to establish open RAN standards at the international organizations, and whether or not there's anything we should be doing, we, the industry or the government, should be doing to assist in that effort?
I'm happy to take a shot at it. I don't know, Cheryl, if you want to add to it, but I think that's a complicated question, right? So I think as it relates to the standards for 5G, which is largely being developed at 3GPP, the standards process has largely worked out the way we had anticipated. Yes, Huawei is more active. They do send a lot of people. They do make a lot of contributions in 3GPP. But if you look at the overall IPR out of 3GPP, and you add up the US companies' IPR, or I guess not even just, I wouldn't say US, but allied countries' IPR versus Huawei, I wouldn't say that Huawei is dominating the IPR race at 3GPP. Yes, they have a fair amount, but it's somewhat distributed. If you look at the leadership positions inside 3GPP, it's pretty geographically diverse. It's not dominated by any one region of the world. There's actually bylaws in 3GPP that are set up to prevent that. So I think as it relates to 5G and 3GPP, the standards have come out generally the way we anticipated. We wouldn't deploy it if we thought it was somehow compromised from a security perspective. But that said, that's just one particular snapshot. I think there is a longer term trajectory issue with China sending so many folks to standards bodies and making a significant investment in that. And so, I know that from my standpoint, we have had several conversations with both the administration and with folks on Capitol Hill about, how do we incentivize more U.S. participation in standards? And that has largely been done by the private sector, right? So the standards process today, is typically, ATIS is the North American standards body that participates in 3GPP. Private companies are members of ATIS, and they participate through ATIS in 3GPP. And I think there is a question of how do we incentivize and create the right environment to ensure that there is, adequate U.S. representation. And I think the pandemic is actually, from talking to my standards people, has actually exacerbated this a little bit because the meetings are much more distributed. They're happening online. It's just created additional challenges for folks. So I do think there's a role for government in terms of convening, bringing people together, ensuring that that in the critical standards bodies of the future, whether it's 5G or next G or another technology like say AI and other things that are happening, that the industry is well represented there, and that we're working together to make sure that our interests are covered. As it relates specifically to Open RAN, 3GPP is really standardizing the radio aspects of 5G. When it comes to actual the open interfaces that I was talking about earlier, a lot of that work is being done in groups like the ORAN Alliance and in the Telecom Infrastructure Project. So there's some other groups that are actually overlaying on top of 3GPP, kind of these open interface concepts.
Yeah, and I'll just add there, echo Chris's comments, certainly on 3GPP as we have some folks involved in that. And I think the process is working, and number of people in the room doesn't necessarily translate to, leadership or kind of, a tilted field and whatnot. And certainly, participation in standards bodies is time consuming and expensive. So it's quite a resource. And so I think, continuing these conversations with the government and focusing and emphasizing the importance of that is good. One thing that I will note, kind of to the point what Chris was making on the number of contributions, I see reports and things that look at, tabulate the number of contributions that one company makes versus another. And I think we need to be careful by just going at number of contributions. I think there's some substance, is it just a spelling fix, or is it an actual substantive contribution to the standard? And I think that's a better way to look at, who's leading, who's actually substantively contributing.
If I can add one point so that we don't fight the battles of the past. As we do more in software interfaces and more virtualized, standards become less and less relevant because you can adapt and put multiple interfaces in the same software, okay? Whereas when things are put in hardware, that's very difficult. You have to have an agreed upon standard that lasts a long time. So that's one, software virtualization helps. Number two, as Moore's law progresses, the need to capture things as and make them hardwired becomes less essential. I can do more in software because I have more compute in general purpose processors. So as we move to 5 nanometer and 3 nanometer handsets, I actually don't believe we need to put the 5G or 6G standard in the chipset as much as have it be programmable software. That's where we're headed. That's just, you know, my view on that.
Okay, thanks for that. Steve, this was sort of directed at you, but I think the others may want to comment as well. There's been discussion even earlier in our conversation about the advantages of being a first mover and the scale that allows that, and the impact of reaching scale first on the ability to continue to do innovative research. With Open RAN systems, there are lots of sort of experimental programs and some commercial scale programs going on out there. But I wonder if you would want to comment on how we can get to larger scale. I guess Chris mentioned working with Telefonica and Vodafone going forward, but it seems that in order to convince people that this is a real opportunity and also to start taking market share away from Huawei, somehow soon we have to get to scale. Would any of you, Steve, Chris, any of you like to comment on that?
Well, there's sort of two elements to it. One, you need to be a reasonable alternative. And I'd say things are getting close. I don't think they're quite there yet, candidly, okay? So you have to meet all of the needs that someone has. No one wants to put equipment up on their towers that's a dead end, right? So that's one ingredient. Then the second is, how do we actually get scale to drive out cost to be cost competitive? Okay, like I was saying before, you know, Huawei's cost for a radio or an antenna is going to be half of what an O-RAN vendor can get that for, okay? And there are discussions about how we aggregate buying power, right? Does it come to that? That's one approach if you want to build the same type of networks that Huawei does. Or, as was called out in the research study, do we move to drive down the cost of alternate radio architectures, particularly these digital heavy ones, such that you don't have to compete with Huawei's scale, you change the playing field, right? Both of those are viable pursuits.
Yeah, I agree with Steve's last point that if we're trying to compete with Huawei at their game, you know, they have such reach, and just the Chinese market by itself is so massive that it just makes it really challenging to try to really compete at that level. So I think the idea of, and that's why I think this Open RAN technology discussion that we've been having is so appealing, because it is a way to kind of change the game, you know, and move away from their inherent strengths and really maximize the strengths that we might have in terms of innovation and software and other things where the US has traditionally been a leader.
Yeah, and I'll just add into kind of, you know, from our perspective, this is where the focus on the applications, I think, becomes so important, right? Innovation doesn't have to wait. It can start now. And I think, you know, if we can focus on the what, you know, other players, software companies, cloud companies, right, we can develop this whole ecosystem of new applications, which is where the real, I think, value and opportunity is. And so, you know, trials and pilots and things like the Department of Defense is doing, I think is very beneficial in pushing and getting more players into this space and building up the ecosystem here.
Okay, Cheryl, I might ask you something I asked Joe Evans about whether or not there are any inherent advantages in terms of security with software-based systems, cloud-based systems. You're an expert in that. You've spent your whole career thinking about that. Do you have any comments?
Yeah, absolutely. So, we see it as a big opportunity. I think the transition from the purpose-built hardware to cloud, right? You now have an opportunity, as we see it, to start to shift the security advantage. And so, being built in the cloud, what 5G can do is inherit the cloud scale and reliability and security. And so all these capabilities can be rapidly deployed, scaled, segmented, with their tailored security measures applied. What you also have is embedded artificial intelligence and machine learning capabilities that can autonomously prevent, detect, respond to, predict sophisticated threats. And as these network functions are carried out in software, right, the tools, your tool that you have for security increases, right? You have network slicing, containerization, as Dr. Evans mentioned, the zero trust software-defined perimeters, right? All of this further enhances security. And I think too, there's a supply chain aspect to this as well, because it really plays into the strengths of US software and cloud competency, and so you have this opportunity to get many more trusted vendors that can develop the capabilities. So we see it as a real opportunity.
Okay, Bryan, you might want to jump in on this as well, but for all of you, we've discussed a lot, including Joe Evans, the importance of having leadership in semiconductor technology. And there was allusion made to lots of legislation that's in front of the Congress to, for instance, support building fabrication plants in the United States. Are we behind the Chinese in key technologies that affect key hardware technologies, especially semiconductors, that affect the 5G supply chain, or antennas for that matter, the radio network? And do we need to have a robust US government investment to make up the deficit we have in terms of technology with China, if it exists, if that's a realistic assessment? So I know Steve has some thoughts on that, but any of you want to jump in? Nobody wants to jump in that briar patch?
No, I'll be happy to. So one of the, remember, wireless operators need viable commercial models. If their operating expenses are too high, it's hard for them to generate the resources for further investment. One of the biggest sources of operating expense is energy, okay? With 5G, you're lighting up a lot more spectrum with a lot more complexity, and it burns a lot of energy. Huawei was an early leader in pursuing gallium nitride to drive energy efficiency, and that gave them a lot of the early lead in 5G radios to be preferred. I would talk to some operators that said the energy efficiencies were so great that the Huawei equipment would pay for itself in 5 or 6 years, right? Now, Huawei has been slowed down a bit with many of the tools that have been mentioned on this call. And folks like Ericsson and Nokia have now been investing more there. So that gap is closing, right? But it's not, there's nothing disruptive on the horizon from the big vendors, which creates both opportunity and a place of leverage to take away Huawei's strengths, if that helps.
Bryan, do you want to weigh in on that?
The issues are, like Steve said, there's an efficiency issue that we need to improve our own microelectronics efficiency. I would argue in terms of sophistication, US microelectronics are on par with what Huawei is generating. It's not like Huawei's got a secret sauce that's generating better microelectronics. It's just they put the effort into integrating it into their kind of integrated package that they're offering to their mobile network operators, and then also they're doing it at scale, at a scale that we're not doing here in the United States. So there's essentially an engineering challenge there. There's a little bit of a technology challenge the US needs to overcome by investing more in the semiconductor industry. then there's a separate issue with regard to the semiconductor industry or the supply chain, and to what degree that needs to be onshored, and how do we manage it better to give us a more resilient U.S. Semiconductor supply chain. But I think that's a separate issue from the underlying technology.
Okay, we've pretty much reached the end of the time frame that we had set out for ourselves. Does anyone have any burning final thoughts that they'd like to express before we sign off?
I'll just make one comment on the importance of the signal. So, I think the administration and our legislators have done a really good job, I think, in signaling to industry the importance of this, of 5G, of innovating in this space. And so, I think, from our perspective, we would love to see that continued, that championing. And I think also the signaling of the importance of cloud and software in 5G is critical, right, to being able to get more folks into this and really grow the ecosystem of players. So
I think Cheryl makes a great point there. That's well said.
Okay, well, on behalf of Hudson, let me thank all of you for your excellent contributions to this discussion. I learned a lot, and I hope our viewers have learned a lot. And I will turn it over to Bryan, who's the real organizer of this event, for any final thoughts and sign off. Bryan.
Thank you, Tom. I'd like to thank everybody for being on this, being at the event, being on this call. It was, I think, an excellent opportunity to talk through some of the issues surrounding the 5G industry in the United States. How do we create a viable 5G telecommunications ecosystem in the United States, to use Cheryl's term, because that's really the important consideration. It's not just mobile network operators, it's not just semiconductors, it's the whole group of organizations that take spectrum and turn it into a useful piece of information for a user. And that's going to involve a model different than the vertically integrated model that Huawei and some others have been promoting. So Open RAN is the path to do that, and a path to a US getting an advantage. So we think that this two-pronged strategy going forward is the way we should be pursuing it. It's consistent with what I think DoD is looking at with regard to their demonstrations. And I think we just need to all look at ways that the US can better foster that two-pronged strategy through the microelectronics initiatives and through the moving up the value chain to get to more virtualized networks that are the future of 5G. So thank you very much to Dr. Joe Evans for speaking today. Thank you very much to Steve Papa, to Cheryl Davis, and to Chris Boyer for being here. Thanks to Dan Patt for working with me on the study. And very much thank you to you, Tom, for hosting it. We appreciate it.